So thank you. Today I'm going to talk to you, as David said, I'm going to talk to you about some of our work in social media visual analytics. And so this is about text analytics in addition to visualization, information visualization software in particular. This work has also been done in conjunction with some of my colleagues at the lab here, Robert Patton, Tom Potok, and Chris Simons. So basically, as you see in the news and throughout the literature and magazines and press, social media is such a big phenomenon today that it's already changed the world, and it continues to change the world at a ever-increasing rate. We see it anytime there's sort of like a global event, like the Boston Marathon bombings, London riots, also like sporting events, and just any kind of large-scale event. Whether it's national in the U.S. or global significance, we can see it in the social media streams. Most of these services provide a way to sort of tap into those streams and analyze their data, but it's like, essentially it's like drinking from a fire hose because they're very high throughput streams. If we think about things, these text-based services like Twitter, they often have sort of their own language, or through acronyms and various shortenings of words, and so it's very difficult and a very hard problem to sort of analyze this data. Furthermore, there's a lot of noise in the streams, but there are actionable signals. So if we can sort of filter these streams to find those signals, they can be very beneficial. And so the technical approach that we've taken is, so on the far left of this diagram, basically the problem that we're trying to deal with is interactively analyzing these high throughput, high velocity, and very noisy streams to identify these signals. And so we've basically initially we've latched onto the social media streams, specifically Twitter, to sort of build our system. But we can also deal with RSS news feeds. And the system could be extensible to deal with things like blogs or discussion sites, any sort of textual information that would come through in a stream format. So we have a pretty robust data management system that can consume these feeds or these streams. We can run analytics on the streams or the data that comes through the streams automatically. And we also have visualization clients. And since this system follows a visual analytics paradigm, the analytical models, the automated analytical algorithms, and the visualizations are very tightly coupled, so that through the visualizations I can change the analytical models, and furthermore the analytical models can be used to illuminate or highlight things in the visualization. So it's a complete system that includes the human in the loop, so that we also tap into the power of human computation through things like perception and cognition. And so the ultimate, through this sort of feedback loop, through this entire system, we hope to reveal insights specifically in streaming textual information. And so just a bit deeper into that sort of data management part of the system and sort of the whole analytical components as well. On the far right of this, it shows, just like before, where we consume the streams into a, basically in this box is representing basically like a listener or an archiver process. Basically, if Twitter provides a stream of information coming through their system, this listener essentially consumes that feed and stores it to some archive. So it's just sitting there listening to a feed, essentially. Once it's in this archive, a separate process indexes the data and also applies analytics to it, for example, like sentiment analysis, to store it, and we use the Elasticsearch index system. And so once it's in there, we can search over anything that we've indexed over, like the any text that's in the social media data information. We can also search over things like geographic coordinates and time and other sort of multifaceted search items. And furthermore, it's available to clients, for example, like visualization clients, which I'll show you in a minute, some of those, it's available through a REST API. And so this system it's got a series, so the listener runs independent of the indexer sort of runs independent of the client, so it's a very robust and a fault-tolerant system. Furthermore, it's flexible so that we can plug in new analytics to run automatically. We can also run multiple listeners to, provide information into this archive that's indexed automatically. So it's a very sort of a distributed, fault-tolerant, and a robust system to help us automate the stream analytics. The stream listeners that listen to the feeds for the Twitter, the case of Twitter, mainly operate in three modes. One is Twitter provides, and so all these are available to anyone with a developer ID, and so essentially you provide your developer ID to our data management component that you procured from Twitter. And so anyone with a Twitter account can get that ID. And it runs in three modes. One is just a random 1% sampling of the information, of any information that comes through Twitter. Twitter runs a random sampling and they provide you a stream with that information. So with that, since it is a random sample of everything, you sort of can see the ebb and flow of information throughout the day. So we can see when people typically are awake and when they're asleep, just because of the activity in the Twitter random sample stream. Another way you can listen is by defining a box of interest through geographic coordinates. So you give me the left, right, bottom, top for this box, and I only get tweets from Twitter that have that have latitude, longitudes within that geolocation. Of course, that you only see about 1 to 1.5% of the tweets that come through Twitter have some kind of location information, so you're greatly reducing the number of tweets that you will see. But it is a neat way to sort of pare it down to just a geographic area of interest. And then finally, we can specify a comma-separated list of keywords to tell Twitter I only want tweets that contain at least one of these keywords. So there are three modes then that we can set to basically consume information from Twitter. And you can run any number of these. If you run two 1% samples, you'll get the same sample from Twitter, but I could specify multiple geographic regions of interest, read the 1% sample, and also start a number of keyword-based listeners all in parallel. And so these all use the Twitter Stream API. So the geographic and the keyword base are subject to rate limits within Twitter. And I should say, too, that Twitter provides data resellers, so you can increase that 1% to higher percentages, but you basically pay the Twitter reseller. But our system would plug into that higher rate, independent of the other elements. So I mentioned before some of the analytics that we run in an automated fashion on the data as it comes into the system. One thing we do is sentiment analysis, and so we initially set up a naive Bayes classifier, which gives us anywhere from 80 to 90% accuracy to just estimate the positivity or negativity of the tweet as it's coming through based on the textual content in the tweet. And so this is represented here in a plot where the blue bars indicate positive sentiment and the orange in this case indicate negative sentiment. So this is just kind of giving you a hint of some of the visualizations that I'll be going into further detail with in a moment. But ongoing work is to sort of expand this. We're looking at ways to sort of, so positive, negative is fine, and that does give me a sort of an indication about what's going on in the world and how people sort of feel about what's going on in the world. But we want to get a little finer grain detail on what's going on so that we could say not only is it positive, but it's happy or cheerful, or if it's negative, maybe it's depressed or something like that. And then also tying that to a context or a topic. That's some of our ongoing work. Let's see. Okay, so this is the the tool that is called Matisse that lets you sort of visualize the information in the index. And so on the right hand, or I'm sorry, the left hand side, we had the filter panel. And so from this, basically this is where you can run a multifaceted query over the index. So I could search for terms of interest. I can narrow it down to a start and end date. Also geographic parameters. I can specify these by typing them in on this side, and then I can filter it down and actually see the raw tweets when I click this Get Tweets button. In the middle, we have our temporal visualization panel. And on the bottom, you see the overall. So for the whole index, I can see a longer time slice on the bottom. This is what we call our overview panel. And so in this case, it's showing a week's worth of data, and I can see sort of that cycle of activity in the Twitter information. And these marks that you see, these vertical marks every now and then, those are the 12-hour marks. So kind of gives you an indication of when days start and end. And this is a very interactive system, and I'll have a movie in a moment to kind of convey that interactivity. But on the bottom, like I said, this is the overview. You can make a selection in this view, and you see the details in the top. So then you see like the minute level statistics. Each of these bars would indicate a minute in time and giving you the positive and negative sentiment activity. So the you can see on the bottom the negative bars basically, or the negative sentiment counts, are conveyed by these bars that go down, and the positive by the bars that go up. And so just finishing out the description of Matisse, right next to the temporal panel we can see a little map view that kind of conveys the geospatial distribution of the tweet. So for whatever selection that they've made, which is indicated by these handles here, it's showing me basically a heat map of where typical tweets are located for that time period. And so darker blues in this map indicate a higher frequency of tweet distribution in that area. And then finally on the far right, for this selection, you see the top terms. And so it ranks these based on the counts of those terms. So it's a term frequency list, essentially. And you can actually click on those, and it will populate query parameters, and I can get all the tweets for a word that I click on. So in the bottom, that conveys again that positive tweets are indicated by the blue bars and negative by the orange bars that are going down. And so what we can see when we sort of look at this, and this is looking at, in this case, looking at the random, the 1% random sample from Twitter. So we can see sort of those cycles of patterns that we typically see, and it's very very dependent on what time it is in the U.S., because most of the users for Twitter would be in the United States, but it is a global system. But typically, around midnight, activities falling off. Around lunchtime or early morning, activities picking up, and it typically kind of levels off in the afternoon, and then it picks up again around prime time. And so you can kind of look at that and say that's sort of like a normal pattern for a day. And if you see any kind of a deviation, like on this day there was a pretty big spike in the afternoon, we can say that there's an event, and we can investigate that with this tool to see what the event was, where it was at, and whatnot. So this is just a little more detail describing a lot of the things I kind of talked to a moment ago, but again, this is showing on the top on this one, it's showing a total frequency view. So we can turn off the sentiment view that splits the sentiment into two bars and just show it as an overall total frequency. And that's what's happening here. So you're just seeing the counts. Basically, that's just adding the positive and negative bars together and showing only one bar. But the bottom timeline, again, conveys for a larger timeline the overview or the context. So we can make a context selection, and then in the top, the detail view, we see the fine-grain statistics on those for that timeline. So we see like the minute level statistics up here on top. And then we can again make a selection up in this view, and which is also propagated to the other views. And so as the user moves the mouse in the display, you see a mouse hover query. which gives you the number of tweets, the number of positive, negative, and other statistics that might be stored in the index would be exposed on the mouse hover. And so again, total frequency view just kind of shows the bars together. The split sentiment view gives you those two sort of separated along the middle of the temporal timeline there. So in this case, I was going to show a quick demo from the week of the Boston bombings, just to kind of convey some of the interactivity of the system. So this is from the week 14 to 20 April in 2013. And this is the same that I mentioned before about seeing, normal pattern in Twitter, and then we had this event that shows up as a spike. And that's actually when the bombs started going off in Boston, and you can see it in the movie in the top here. I was just going to point this out. And so we're going to actually have to switch out of the PowerPoint to go to a movie here. And so I'm going to kind of talk to this movie as it plays. So when we initially look at it, we could look at this system and we could notice this sort of spike here on the second day and select that whole day. And so then we see the minute level statistics here, and I could go to where that spike is. You can kind of see some spikes in the bar chart on the top here. And if I want to investigate, I just click and drag my mouse over that area, and notice that the map has changed. And so it's showing me the geospatial distribution for just that time that I've selected in the detail time view. And you can see some darker spots in the New England area. And if you look at the top terms, you see things around Boston, pray for Boston, police, explosion. So you can quickly put together what's going on for that time period. And then if we click on pray for Boston, we can get the tweets related to that from the filter panel on the far left. And we can actually get really fine-grained detail about what people are saying about it related to that term. So we can take it a step further. So we can configure the panel and hide the filter view, and we can look at the day and when they caught the suspects. So if we look at the details of that, the minute level statistics, we can see in a couple of minutes where the Twitter stream sort of dropped off. We have some gaps in the data. But also we see a spike here, both on the positive and the negative. Far more negative on this day. Again, activity in the New England area, and you can see from the top terms, suspect, custody, Boston police. And so if I click on suspect, I can get the tweets related to that, and I can see, based on the information coming from these tweets, that the suspect has been caught, and sort of the event is over in this case. So it's a quick way through this system. Switch back to the view here. You can go from, here's an overview of what's going on in the Twitter realm right now, which essentially is like the pulse of the world in a sense. And I can see an anomaly or a feature in that space, and I can quickly sort of drill down to investigate it to identify what has just happened in the world. And we can see any sort of a national or global significant sort of event, we will see it in the Twitter stream without question. And so we can take that then and extend it so that we can represent a number of topics where we have each one of those as a stream representation, and we can analyze all those in the same way that I just showed you, which is looking basically at one stream. But we could set filters like I talked about a minute ago to look at specific geographic locations, or for looking for specific terms, or the 1% sample, to investigate thousands of items at once, thousands of topics at once. And that's what this is showing. So each one of these represents, in this case, it was a disaster management type scenario. We were looking at tweets related to Hurricane Sandy and analyzing how topics were discussed around things like fuel and energy outages and things like that. And so this showed sort of that view of the storm from the eyes of Twitter. And we are looking, ongoing work is to look at other ways to sort of visualize this information. This is a alternate view of the graph I just showed, but in this case we're using something called parallel coordinates, where each of these vertical axes represents one of those topics like fuel and energy, and we're showing the tweets in a different way. Rather than looking at the temporal aspect of it, we're kind of looking at the overall statistical distribution of that space. And this is using a related technology that we have called Eden, that's actually an open source tool that would be you could get to from the site that David mentioned earlier. So future work, as I've sort of mentioned earlier, we are spending a great deal of time developing these new emotion classification techniques, and also there are some visualization techniques associated with that. This is a machine learning based approach, so it's something that could be sort of automatically generated and set up. Doesn't require a lot of beforehand development to sort of develop a new topic or emotion that we want to analyze. Also, we are looking at expanding the topic stream listeners to sort of hook into the machine learning framework to do just what I said. And also sort of just automating the whole suite so that the listener, the classifier, and database index and visualization all sort of works together to form a streaming textual information system that goes beyond Twitter, but also into like news services, which in some cases can have less noise and more credible information often. So some kind of a staged analysis where you could go to the news sources for more trustworthy and then investigate sort of breaking news in something like a Twitter type tool. So that concludes the technical talk. Now I would open up to any questions that the participants may have.
Well, Chad, thank you very much for an interesting presentation. For those who are listening, if you would like to email or text a question, those can be emailed or text to ttpd@ornl.gov. And we do have a couple of questions. First of all, Chad, what makes the technology that you've developed unique compared with other similar products?
So I think that the exploratory nature of the tool, so we can go from a high-level view of, this is, a global view, sort of a summarized or aggregated view of what's going on in the world, down to the fine-grained, high granularity sort of details. That sort of sets it apart from what we've seen in this same sort of line of analytics. Typically, most tools don't also give you the visualization capabilities that we have and the ties directly into the automated analytics. Furthermore, the sort of the plug-in architectures that we've developed are very unique, I think, for this.
So from a commercial perspective, what kinds of companies would be interested in using a tool like this?
So we've, the project was developed to look at global events for like disaster management, or even like sort of law enforcement. We could see uses for it, but we think it has a big potential also in like commercial applications. So for like companies that wanted to set a topic stream to analyze, say, products or marketing campaigns. We captured tweets during the Super Bowl to analyze around like some of the ads and things like that. So you could even imagine a system that was set up to where you had multiple ads staged, and you could gauge the sentiment of the first ad to see which one is run for the second case. So we see a lot of application in that area as well. But I think we've mainly developed for disaster management, law enforcement. Commercial is something we're interested in pursuing.
So I think you may have already answered this, but if you look at the applications beyond that, do you see military applications? Do you see product development applications?
I think that there could be applications in that area. We see calls from like the NIH and others that are interested in sort of gauging psychological things like post-traumatic stress disorder. So I think there could even be medical applications as well to gauge a sector of the global community to see how the sentiment or something has changed.
So in terms of implementation, are you limited to a particular operating system at this time?
No, the system is all developed in Java, so it's platform independent. We also have some web-based components that would also be platform independent, but they would facilitate sort of setting something up and accessing it via a URL. The Matisse tool that I've shown is a standalone application, so it would run as an app on your Mac, Windows, or Linux desktop. Just gives you a little more scalability since it is a standalone application.
So if a company were to license this technology, in your view, what's the timeline between handoff and actually being able to have a product that could be sold?
It's a little tricky to say. I would say, you know, this tool, we can apply it to the stream now. I would guess around probably 6 months or so before we could sort of operationalize it and tailor it to a specific application or a specific use, and to get it installed and everything. So that would be my guess. Yeah.
Well, that's all the questions that we have. Once again, thank you very much for joining us this afternoon. Hope you have a great couple of weeks until we meet again. Thanks.